Hello and welcome to this course Machinery Fault Diagnosis and Signal Processing. Today's topic is IC engine fault diagnosis, and in this IC engine fault diagnosis today we are dealing with the spark plug gap fault. Okay. So this is BE major project for the session 2014-15, condition monitoring of 4-stroke petrol engine by using acoustic analysis. Now, all the spark ignition engines, the spark plug is installed at the top of the engine, and whatever the air fuel mixture which is being compressed in the IC engine, that air fuel mixture is ignited by providing a spark at the spark plug, and because of the spark generated by the spark plug, the air fuel mixture get burned out, so combustion takes place, and because of the combustion a thrust is developed, and it pushes the piston, and this is how a power is generated. So the working of spark plug is very important, and the working of spark plug also includes the gap between the spark plug electrodes. So a proper spark plug is critical to engine performance. Spark plug gap affects the performance, such as how an engine starts, runs and idles. So if the spark plug gap is too high, then lot of voltage is required to overcome the gap. Sometimes for the engine it is not possible to generate such a high voltage, and that is why the spark may not be generated. And when the spark is not generated, then the air fuel mixture is not burned, and the unburned air fuel mixture goes out of the engine, and the mileage of the engine comes down drastically. At the same time, the flue gases which are coming out from the engine, it also contains a lot of unburned carbons, and it affects the environment very badly. So proper combustion of the air fuel mixture inside the engine is very important to keep the environment clean and to get the maximum efficiency of the engine. At the same time, if the spark plug gap is too low, that means the spark generated is very weak, and it may not burn the air fuel mixture completely, and that is why unburned fuel maybe come out of the engine, and the efficiency of the engine is not properly attained. So maintaining a proper spark plug gap is very important. The gap is the distance between the center and the side electrodes. It is the distance between the two electrodes, one which is at the center and one which is at the side. So arcing occurs at a proper voltage that ignites the fuel and generates the combustion that makes the engine run. So maintaining a proper electrode gap or spark plug gap is very important, and in this project we try to find out the optimum spark plug gap by using acoustic analysis, and we try to diagnose the spark plug fault in the IC engine. Now, what are the firing frequencies? So what are the frequencies that we are looking forward while monitoring the fault in the IC engine? So engine firing frequency is given by the formula n upon 60 into 1 upon k into n, small n, and the answer is in hertz. So where capital N is the rotational speed in RPM, of the engine, small n is the number of cylinders in the engine, K, the value of K will be 1 for 2 stroke and value of K will be 2 for 4 stroke. And now what are the different engine faults? First we look at the different engine faults. The engine faults includes loss of power, that is because of the weak compression, because of the fuel, poor fuel quality, or some electrical problems, that means proper voltage is not provided to the spark plug, and sometimes the problem is because of the spark plug defects. So in this presentation we are dealing with the spark plug defects. Now these types of engine defects can be monitored uh, by monitoring cylinder combustion pressure, because the proper working of the engine can be ensured by uh, the proper combustion pressure inside the engine, or we can monitor the faults by using engine vibrations, or by using acoustic analysis of the engine also. Now this is the engine that we have selected for the experimentation. These are the specifications of the engine. It is 87.8 cc engine, 4 stroke single cylinder engine of the two-wheeler Scooty Pep. Okay, so the Scooty Pep engine we have used for the experimentation. Then we have taken the acoustic signals of the engine at various spark plug gaps. We maintain different spark plug gaps, and by analyzing the vibration acoustic signals of different spark plug gap, we can find out the optimum spark plug gap from those analysis. So this is acoustic signal in time domain as well as in frequency domain. This is for the healthy conditions at 2000 rpm. So initially when the working is normal, so there we have taken the readings. Then we have changed the spark plug gap, and after changing the spark plug gap we obtained the acoustic signal in time domain, and here you can see that the firing is missing. Then these time domain acoustic signals are analyzed by using time domain statistical parameters such as RPM, kurtosis, variance and skewness. So these are the statistical parameters at various RPM, that is at 2000 RPM, 2500 RPM, 3000 RPM, 3500 RPM. And this is one plot of RPM versus kurtosis. So on the x-axis there is RPM, that is 2000, 2500, 3000 and 3500. So these are the four speed limits that we maintain during the experimentation, and on the y-axis there are kurtosis values. And we know that kurtosis values around 3 is indication of the normal working of any machine component of or any IC engine, and when the value of kurtosis goes away from 3, that means some defects or some fault start coming into the engine or into the machine. So here also we can see that uh, for the spark plug gap of 0.6 mm, the variation of the kurtosis values are indicated by blue line. Then the spark plug gap of 0.7 mm is indicated by a red line. Then spark plug gap of 0.9 mm is indicated by a green line, and a spark plug gap of 0.8 mm is indicated by a purple line. Now here we can see that we can see that for spark plug gap of 0.8 mm, the kurtosis value remains at around 3. So that means uh, 0.6, 0.7 and 0.9 are not the optimum spark plug gap that we are looking for. The optimum spark plug gap is 0.8 because the kurtosis values remain near 3, and that means the engine is working very well. There are less misfirings, or there are less noise, acoustics, abnormal acoustic signals are not coming from the engine, uh, and that is why the optimum spark plug gap we can say that is 0.8, whereas 0.6 and 0.7 are too small uh, uh, to properly burn the air fuel mixture. At the same time, 0.9 is too high to generate an air fuel mixture. So here we have implemented an acoustic analysis for finding the optimum spark plug gap in the IC engine. So this study has shown that a simple non-destructive acoustic measurement techniques offer information of the behavior of a running engine mechanism. The benefits of this non-destructive technique is no detrimental effects to the engine performance and requires little or no engine modifications. Okay. Kurtosis is the most important time domain statistical parameters of the engine fault diagnosis. So here, out of the 4 time domain statistical parameters that we have measured, that is RMS, kurtosis, variance and skewness, kurtosis is showing the results in a better manner. We can conclude from the analysis of the kurtosis values, and that is why kurtosis is one of the most important time domain statistical parameters for finding a fault in the IC engine. By properly control over the pollution can also be achieved when the optimized engine performance by proper fault diagnosis can be done. So, this is how an engine fault, particularly the spark plug gap, can be obtained by using this acoustic measurement and time domain statistical parameters, particularly kurtosis. So thank you.